Okay, this video says, recall the remainder estimation theorem says that the remainder of order n for the nth degree Taylor polynomial Rn of x satisfies this inequality. Okay, where m is the maximum of the absolute value of the n plus first derivative on the interval a to x. Let f be the function with derivatives of all orders. Okay, and then we're told that P4 is the fourth degree Taylor polynomial for f centered at x equals 6. So remember, that's really your A, where your center is in our theorem. And then here's our approximation. So that's x. And the graph of the fifth derivative in absolute value is below. Okay, so they'll need that. Find an upper bound for this error around your answer to, and so I changed it because for reasons you'll see in a minute, or once we finish, to one significant digit. Okay, so we need this, right? So I'm gonna write that down and really just kind of follow the formula. So it's R sub 4, 6.3. Okay, that's the error when we use the fourth degree Taylor polynomial centered at 6. So this m we got to find. That's like kind of the most difficult part of this formula. Otherwise, you're kind of just plugging in. X is 6.3. Okay, and a is 6 to the 4 plus 1 divided by 4 plus 1 factorial. Okay, so everything here is taken care of. We just got to find that. So what was that again? If we look at what our theorem says, m is the maximum of the absolute value of the, so the n plus first derivative over here, it would be the fifth derivative. Okay, you could use t or x in this case, but we'll just use t on the interval. So a to x would be 6 to 6.3 in our case. So how are we going to find that? Well, what do you know? There's a little graph down here that has the graph from 6 to 6.3, and we can tell that the maximum, since it's increasing on the entire interval, is that. Okay, so that equals 1.9845. Now look, you could use that number, you could use any number bigger than it, but obviously that makes the most sense because it'll let you say something a little bit more precise. So I mean, you could say like 10 million and put it in for n, but that wouldn't be that helpful in terms of bounding the error is what we say. So so this is 0.3 to the fifth divided by 5 factorial. So if I put that in the calculator, I'm getting a really tiny number. I'm getting 4.0186125 times 10 to the negative 10. So that's really tiny. That must mean this 8 is really close to the true value if the error is bigger than that. So we're going to round that. So what I mean by one significant digit means we're going to round that to 4.0 times 10 to the negative 10th, and we're going to have that be our answer. In any case, hopefully you acknowledge, as crazy as this problem or this formula looks, ultimately you're just kind of plugging in as long as you memorize it. And then this m here is either given to you or if you have to find it, it shouldn't be too hard to find, at least if you're taking the AP exam.